So here we have a function given by tangent of x minus sine of x divided by sine cube x. So we have to find the limiting value of this given function when x tends to 0. So let us begin by first converting tan to the ratio sine x over cosine of x. So we have minus sine x divided by sine cubed x, which is going to be equals to limit x tends to 0. So we take we combine the two functions, sine x over cos x and minus sine x, and that should give us sine x minus sine x times cosine of x divided by cosine of x times sine cubed x. Now we're going to take sine x as the common factor in the numerator, so we have sine x multiplied by 1 minus cosine of x divided by cosine of x times sine cube x. So we are going to cancel sine x from both the numerator and the denominator, so we have 1 sine square remaining in the denominator. So that leaves us with limit x tending to 0, 1 minus cosine of x divided by cosine of x times sine squared x. Now sine squared x can be further broken down as limit. We have limit x going to 0, 1 minus cosine of x in the numerator divided by cosine of x. So we have times sine squared s, so sine squared x can be rewritten as 1 minus cosine squared x. That's because we have the identity 1 equals sine squared x plus cosine squared x. So that gives us limit x tending to 0. We have 1 minus cosine of x divided by cosine of x. So we have 1 minus cos square x, so that will be 1 minus, so this is an identity a squared minus b squared, because we can write 1 as 1 squared. So we have 1 of cosine of x multiplied to 1 plus cosine of x. So the 1 minus cosine of x terms is common in both the numerator and the denominator, so we can cancel it out, and that leaves us with limit x tending to 0, 1 over cosine of x multiplied to 1 plus cosine of x. Now we substitute for the value of 0. We have cosine of 0 multiplied to 1 plus cosine of 0. So cosine of 0 is 1. So that gives us 1 divided by 1 times 1 plus 1, which will be 2. So we have 2 in the denominator. So this is going to be the limiting value of the given function when x approaches 0. Let's do another problem. So here in this particular question, we have to determine the limit of the given function, which is tan x minus sine x divided by x cubed. So we have to find its value, limiting value, when x approaches 0. So let us begin. Anyways, before beginning, I'd like to point out that when we substitute for the value of x, so we'll have tangent of 0, which is 0, minus sine 0, so that is also 0. So that means we're getting a 0 in the numerator divided by 0 cubed, which is 0. So this is an indeterminate form, so we have to do some a little bit of manipulation here. So let us do that. So we have limit x tending to 0. So like the previous problems, we're going to convert tangent function to the ratio of sine and cosine. So we have sine x over cosine of x minus sine x divided by x cubed. Then we combine the two terms in the numerator, and that is going to give us limit x tending to 0. We have sine x minus sine x times cosine of x divided by x cube times cosine of x. Now we're going to factor out the sine from the numerator. So we have sine x multiplied to 1 minus cosine of x divided by x cube times cosine of x. So here what we're going to do, we are going to first calculate the limiting value of sine x over x, because we know that this value is going to be equals to 1, and then we have limit x tending to 0, 1 minus cosine of x. So we have already taken 1x from the x cube in the denominator, so that leaves us with x squared times cosine of x. So we'll also calculate the limiting value of 1 over cosine of x. So that gives us, so limit x tending to 0, sine x over x is going to be 1, and limit x tending to 0, 1 over cos x, so that is also going to give us 1. So we are left with limit x tending to 0, 1 minus cosine of x divided by x squared. Now we are going to convert 1 minus cos x to, we have limit x tending to 0. So 1 minus cos x, so that is an identity, so it can be rewritten as 2 times sine squared x over 2 divided by x squared. So let me write it down. So here I have used the fact that 1 minus cosine of x is equals to 2 times sine squared x over 2. So now we have 2 times the limit of x tending to 0. We have sine squared x over 2. So let's rewrite it as sine x over 2 whole squared divided by x squared. So that means here we need 1/4 term. So that means what I'm going to do is I'm going to divide the denominator, which is x squared, by 4, and then we are going to multiply it by 1 over 4. So that has been done so that we can, so 2 times 1/4 will be half. So this has been done so that we can calculate our limit easily. So we have sine x over 2 divided by x squared over 4, which can be rewritten as x over 2 whole squared. So that means we have to apply the limit twice, but instead I'm only writing it once here. So this will be equal to half times 1. So we get the limiting value of 1 over 2. So let us do another problem. So here we have the function cos of alpha x minus cos of beta x divided by x squared. So when we substitute for the value of x, so we have cosine of alpha times 0, which will be 0. So cosine of 0 is 1. Similarly, cosine of beta times 0 is also 0. So that gives us cosine of 0, which is 1. So we have 1 minus 1, or 0 in the numerator, divided by 0. So it's going to be an indeterminate form of 0 over 0. So that means we need to recalculate this given limit. That means we need to first simplify it. So let's do that. So we have cosine of alpha x minus cosine of beta x. So what we're going to do here, we're going to use here the identity that cosine of a minus cosine of b is equals to 2 times the sine of b plus a over 2 the times sine b minus a over 2. So let us apply this, and this is going to give us limit x tending to 0. So we have 2 times sine, so we have alpha x plus beta x, or we can say beta x over plus alpha x over 2. So I'm going to write it in a combined form since x is the common factor. So I'm going to rewrite it as beta plus alpha divided by 2 times x multiplied to sine beta minus alpha over 2 times x. divided by x squared. So we have 2 times the limit x tending to 0. So we have sine beta plus alpha over 2 times x divided by x multiplied by sine beta minus alpha divided by 2 times x whole divided by x. So that means now we have to make the denominator, this particular denominator, multiplied to beta plus alpha over 2. So let us do that. So we're going to multiply it to beta plus alpha over 2. This has been done so that we can apply the standard limit sin x over x. When x tends to 0, it gives us a limiting value of 1. So similarly for the second function, we are going to multiply x with beta minus alpha over 2. Now these are extra terms, so we have to get rid of it. So we're going to multiply beta plus alpha over 2 and beta minus alpha over 2 to the entire function. So now when we calculate the limit, so calculating the limit, so I'm going to do it here itself. So we have limit x tending to 0. So the first limit, this particular limit value is going to be equals to 1. The second limit value is also going to be equals to 1. So that gives us 2 times 1 times 1 times beta plus alpha over 2 multiplied to beta minus alpha over 2. So we can cancel out one of the two from the numerator and the denominator. So that leaves us with the product beta plus alpha and beta minus alpha, which can be rewritten as beta squared minus alpha squared over 2. So this is going to be the limiting value of the given function cosine of alpha x minus cosine of beta x over x squared when x approaches the value 0. Let us do another problem. So here we have the function sine of 2x plus sine of 3x divided by 2x plus sine of 3x. So when we substitute the value of x, we get an indeterminate form of 0 over 0. So we need to simplify it. So what we're going to do here is we are going to divide the numerator and the denominator by x. So we have sine 2x. So that means dividing the numerator by x means we are going to divide each of the term in the numerator by x plus sine 3x over x. Similarly, we divide each of the terms in the denominator by x. So we have 2x over x plus sine 3x over x. So in order to be able to apply the limit, so what we're going to do, the first term of the numerator, which is sine 2x over x, so we're going to multiply x with 2 and we're going to multiply the entire function by 2. Similarly, we're going to multiply the denominator of the second term in the numerator by 3 and multiply the entire function by 3. And we come to the second term on the new denominator, so in 3x over x. So we're going to multiply x by 3 and multiply the function by 3. So now we're going to apply limits to each of the terms individually. So this x and x gets cancelled out. So we have 2 times the limit of sine 2x over x when x approaches 0 plus 3 times the limit x approaching 0, the function sine 3x over 3x divided by, so limit x tending to 0 for 2, it will remain as 2, being a constant, plus 3 times the limit of x tending to 0, sine 3x over 3x. So as per our definition, so here's 2x. So as per our definition, so we have in the numerator 2 times 1, so which will be 2, plus 3 times 1, which will be 3, divided by 2 plus 3, and that gives us 5 over 5. So we have a limiting value of 1 when x approaches 0. So let us do another problem. So here we have sine 2x plus sine 6x divided by sine 5x minus sine 3x. So we have to find its limiting value when x approaches 0. Like the previous problem, what we can do is we can divide the numerator and the denominator by x and follow the steps as shown in the previous problem, and then we'll be able to determine the limiting value of the given function. However, I'm going to do this in a slightly different manner this time. So what we're going to do, we're going to use two identities, that's sine A plus sine B is given by 2 times sine A plus B over 2 times cosine of A minus B over 2. And if we have sine A minus sine B, like in the denominator of the given function, that can be rewritten as 2 times cosine of A plus B over 2 times sine A minus B over 2. So let's apply these two identities to both our numerator and the denominator. So that should give us limit when x approaches 0. So in the numerator we have 2 times sine, so 2x plus 6x is going to be 8x. So let's write it down. So we have 8x over 2 times cosine of 2x minus 6x is going to give us negative 4x over 2 divided by 2 times sine, it's going to be cosine 5x plus 3x is going to give us 8x. So we have 8x over 2 times sine. So we have 5x minus 3x, which is going to be 2x. So we have twice x over 2. So we'll get limit x approaching 0. So the 2 and 2 gets cancelled out. We have sine 8x over 2 is going to give us 4x times cosine of negative 2x divided by cosine of 4x times sine of x, which will be equals to limit x tending to 0. So the ratio sine 4x over cosine of 4x will become tangent of 4x times, we know that cosine of negative theta is equals to plus cosine of theta. So we have cosine of negative 2x, and that will become cosine of 2 of x divided by sine x. So now what we can do is first determine the limit of, okay, let's rewrite it down. So before calculating the limit, so we have tangent of 4x. So we're going to divide it by 4x and then multiply it with 4x. Let me get rid of this particular formulas here. So it's ready. This goes away as well. Okay, so we have tan 4x over 4x times 4x times cosine of 2x. So we're going to multiply by 2x. We have over sine x, that should happen simply x. So we have sine x in the denominator. So in order to be able to apply the definition of limit, so we are going to multiply by x and then divide by x. So now we have, so 4x over x is going to give us 4. Now we're going to apply limit to each of the functions. So we have limit x going to 0, tangent of 4x over 4x. This will be one of the limit. The second limit will be limit x tending to 0, cosine of 2x times limit x tending to 0 x over sine x. So we know that tangent of 4x over 4x, the limiting value will be equals to 1, and we have cosine of 2x, which is 2 times 0, so that will be cosine of 0, times limiting value of x over sine x when x tends to 0 will also be equals to 1. So we have 4 multiplied to 1, and cosine of 0 is 1, so we have 4 multiplied to 1 3 times, and that is going to give us a limiting value of 4.